All right, so let's go over this review sheet here. So in this first problem, number one, you have to multiply these expressions out. So you have x times x, which gets you x squared. X times negative 5 gets you negative 5x. You can think that of this as FOIL, first, outside, inside, last, or distributive property. So x times the next two, and then we have negative 6 times the next two things. So negative 6x, and then negative 6 times negative 5 is positive 30. So you clean that up and you get x squared minus 11x plus 30 as your final answer. Here we get 2x times x, so 2x squared, 2x times 4, positive 8x, inside, negative 3x to multiply, and then multiply again, negative 12. So when you clean these up, usually it's the middle two pieces that go together, and get 2x squared plus 5x minus 12. All right, and here, x times x squared, x times 6 plus 6x. Inside is minus 6x, and last two are negative 36. So here notice that the 6x and the negative 6x, they cancel out. And so you should notice this is because you had a plus and a minus, the same problem, but one's plus and one's minus. So this always happens. All right, over on number two. On number two, we're going to have to distribute this to be able to solve this problem. If you would like, I guess you could subtract 1 off of here, move it to the other side with the 9, but I'm just going to leave it here. So 2/3 times 3x, so I have to do 2/3 times 3. My 3's cancel, so I get 2 with my x. Then I have to do 2/3 times negative 6. So I know that 2/3 times negative 6 is going to be a negative, so I just have to do 2/3 times 6. 3 goes into 6 twice, and so I have a 4. And now it looks much better. So on the left side, I have 2x minus 3, because remember that these two items can be put together as a negative 3. So 5x plus 9. So I think I will take away 2x. So I have negative 3 equals 3x plus 9. Take away 9. So I have negative 12 equals 3x. So then I divide by 3, I get negative 4. All right, down to number 3. So number 3, I need to clean this up first. I have to add 3 to both sides to be able to write my two problems. So I have 2x plus 5 equaling 15. The bars are still here. Now I break this up into two situations. Either 2x plus 5 equals 15, or 2x plus 5 could equal negative 15, and I would never have known. So on this left-hand side, I take away 5, so I get 2x equals 10. Divide by 2, so I get x equals 5. Over here, when I take away 5, same steps, but this time I get negative 20, and divide, I get negative 10. So I get two answers. All right, on letter B, I clean this up, take away 8. Right away when I clean it up, x minus 4, absolute value equals negative 6. Nobody's going to tell you to stop, but you have to remember to stop, because this problem is unsolvable. Anything inside the absolute value bars, so what we're saying here is that we have a positive thing. Whatever comes out of here has to be positive because the absolute value bars. And when does that equal a negative 6? Never, because it's supposed to be positive. So there is no solution to this. And if you keep working, keep solving it, nobody's going to know, you're going to get an answer, but you're supposed to stop because there is no answer, because the original question has no answer. All right, let's see. I got to clean this up. It's an inequality this time, remember? So take away 4. I still have a 2 with my x minus 7 still here. 6, I got to divide both sides by 2. So that's gone. So now it's x minus 7 inside the bars is less than 3. So this is a less than problem. This is an and problem. So I have x minus 7 is less than 3. And x minus 7, I switch it to greater than and put a negative 3. So I add 7 over here. So I get x is less than 10. And over here, 7, I get x is greater than negative 4. So remember, and problems come together. Less than 10, so open circle is going to come this way. Greater than negative 4 is open circle, going to go that way, and then they meet up. All right, for number 5. Take away 5 to start cleaning this thing. get a negative 7, x plus 1 less than or equal to 14. Divide both sides to keep cleaning by negative 7. So I have absolute value. I just divided by a negative, so I flip my symbol. I get negative 2. So this is like what we had before. This is also a stopping situation. But let's decide what we have. So what I'm being told here is that I have something that's positive over here, and I'm asking myself, when is a positive greater than or equal to a negative? Well, a positive is always greater than a negative. So it's not that this is never true, this is always true. So there are infinite solutions, which means you draw a line all the way across and you write the words infinite solutions. All right, let's take a look at number 6. I have to divide by 4 to clean this up. So I have 3x minus 1 inside the bar still, greater than or equal to 4. All right, so greater than is an or situation. So 3x minus 1 is greater than or equal to 4, or 3x minus 1 is less than or equal to negative 4 is when you switch it. So add 1. So I have 3x is greater than or equal to 5. Divide by 3. So I get 5/3. Over here, when I add 1, if I add 1 to negative 4, I get negative 3. When I divide by 3, I get less than or equal to negative 1. All right, now 5/3, that's 2, I'm sorry, not 2. That's, whoa, that's a big eraser. Whoops. Let me change that. All right, 5/3 or, all right, so 5/3, remember that's 1 2/3, so I want to put it in the right place. So 1 2/3, maybe about like right there. Everything greater than that, so it's going this way. Remember, or means I'm going to go the opposite way. Less than or equal to negative 1, we'll go that way. All right, so let's see. All right, factoring here. So depending how you like to do this, I'm going to do it using the x's. So in my x puzzle here, I'd put a 15 up top and a negative 8 down here. So something that multiplies a 15 but makes negative 8, I would do negative 5 and negative 3. All right, so I'm done. I got x minus 5 and x minus 3. Now I should have mentioned to check for a GCF there. I think I just went and started this problem because it just looks so quick and easy. But you notice there is no GCF, right? GCF first. All right, looking at the next problem. 2, 5, and 12 have nothing in common, so I'm just going to multiply this by here. So that way I can do my puzzle and put a negative 24 and put a 5 here. So I'm going to use 8 and 3. So 8 minus 3 makes 5, and also a negative 24. All right, so remember, I got x plus 8, x minus 3. I divide these because I multiplied earlier by 2, so I divide them by 2 now. All right, x plus 8, so the 8 divides by 2 and makes 4. And in the back, 2 does not divide by 3, or 3 does not divide by 2, so remember I take this and I stick it right in front. So I end up getting 2x minus 3. And if you start thinking that through, you know, x times 2x is your 2x squared. Here you get negative 3x, and here you get 8x. Well, negative 3x plus 8x, that's where you're getting your 5. And finally, you have your 4 and your negative 3. That's where you're getting your negative 12. All right, this one here, the next one, has no GCF, so we're just going to go ahead and put our puzzle, 48, 14. We're going to be using 6 times 8 makes 48, and also 14. All right, so we're done. The leading coefficient is 1, so x plus 6 and x plus 8. If you want to, you can imagine that you're dividing by 1, but it doesn't change anything. All right, this next problem on the end here does have a GCF. They both have an x to the third in common. So once I take an x to the third away, or factor it out, I have x minus 8, and I'm finished. That's all I can do. So if you want to, you can imagine you're dividing x to the third this way, and you can divide them easier to get your remainder piece. All right, next row. So 531 and 6 have nothing in common. So we are ready to factor. We are going to multiply 5 times 6 to get 30. So 30 goes up top and 31 there. All right, what multiplies to 30 but makes 31? How about 30 and 1? All right, so I get x plus 30 and x plus 1. But don't forget, we multiplied by 5, so I have to divide by 5. The 30 divides by 5 and makes 6. 5 does not go into 1, so I'll bring that up to 5x plus 1. All right. So next one, they do not have a GCF. There's nothing in front of the x squared, so we're all set, and there's no x's in common. So what multiplies a negative 28 but makes 12? We will use 14 times 2. So 14 minus 2 does our job. So x plus 14 and x minus 2, and we're finished. Here, 3, 1, negative 1, and negative 10, nothing in common, so I'm going to multiply my 3 over. So that means I get a negative 30 here, and there's a negative 1 sneakily sitting there. So I'll use 5 and 6. So 5 and a negative 6 add up to negative 1 and also make negative 30. So I'm going to be putting x plus 5 and x minus 6, but I multiplied by 3, so we will divide by 3. So I have 3x plus 5 and x minus 2. All right, this is the difference of two squares, x squared minus 64. If you're using the puzzle, you have a negative 64, and you have a 0, because notice what's happening here is that there's no middle term. So that's why I put a 0 right here. So it's kind of like this problem here, but there's no middle, so that's why we put a 0. So what multiplies a 64 but makes 0 is negative 8 and positive 8. So we will just put x minus 8 and x plus 8, or the other way around. All right, so this first one on the last row here, this is a pretty tough one. The toughest you're going to get. You notice they all divide by 5 and they all have an x squared in common. So we're going to have to pull out that GCF first. So 5x squared is coming out. If you would like, you can write this underneath each one to imagine what's left, if that helps you. So what's left in the first spot is x squared, negative 20 divided by 5 is 4, and 1x left. And finally, 15 divided by 5 is 3, so plus 3, and that's it. So now I have to go ahead and do my puzzle. So there's a 3 and a negative 4. Well, what multiplies a 3? The only thing is 3 and 1. And so I have two negatives to make a negative 4 and to make a positive 3. So we're going to have 5x squared. We're going to have x and x, and let's see, minus 3, minus 1, and we're done. All right, looking at the next problem, they have an x in common, so I'll pull that out, and that leaves me with x plus 7. That's all I can do. All right, looking at the next one, 4x squared, so they all have a 4 in common, 4, 12, and 8, I'll divide by 4. So pull a 4 out, which leaves me at x squared plus 3x plus 2, right? Everything divides by 4. Okay, so what that would happen there then, I would have do my puzzle, put a 2 and a 3. So use a 2 and a 1 to multiply to 2 and add up to 3. So I have a 4, and I'd have an x plus 2 and an x plus 1. All right, on my last problem here, they all divide by 3 and x. So we're going to pull out a 3x and see what's left. So I'm dividing these by 3x. So that leaves me with x squared plus 4 plus 7. 4x, that is. Sorry about that. Okay, so let's take a look. Put a 7 here and a 4 there. Now, the only thing that multiplies a 7 is 7 and 1. But 7 and 1 don't make 4, so I can't do it. So this is done. This is finished right here. There's no more factoring that can be done. This part right here, you would call that prime, but the 3x is already out, so this is my answer. Okay, and that is it. Now, we did some tougher problems in class. I just want to go over one more problem that you might see something like on your test, like what we did in class. So let me just write a little extra one down here. Let me see. How about this guy? Let me pick one. Sorry. All right. Let's say I had 10x to the third plus 4x squared minus 14x. If I had to factor this completely. So I notice they all divide by 2, and they all have an x. So I'm going to pull out a 2x, which would leave me with 5. 10 divided by 2 is 5, and have x squared. 4 divided by 2 is 2, and 1x left. 14 divided by 2 is 7, and there's no x left. Now when I get to here, I need to try to factor this. Well, this is one of those harder factoring ones. Remember, I have to multiply 5 times 7. So that would get me my little puzzle, 5 times 7, I get negative 35 there, and a 2 here. So I'm going to use 7 and 5. 7 minus 5 is 2, and it also gets me negative 35. So when I go to factor, I would have x plus 7 and also x minus 5. But remember, we multiplied by 5, so I'm going to divide those by 5. So my final answer, this 2x stays here. My first piece was the 7/5, so it becomes 5x plus 7. And my last part, 5 divided by 5 is 1, so x minus 1. So just don't forget that we did those in class. I guess I forgot to put one on here, but that could be the hardest that it would get. All right, I'll see you later. Bye-bye.